All right, well, hey, it's exciting to have this opportunity to have you join us this morning. Thanks for taking the time. I'm just going to go ahead and jump right in and introduce friend and former colleague, Dan Haig. Dan?
Hey, thanks, Chris. So, hi, everyone. Thank you for joining. My name is Dan Haig, and I'm the regional manager with Esri here in St. Louis, Missouri. And I've been working with many of our customers throughout the Midwest for the past 27 years. So most of them state and local government customers. And I'm really glad you could join us for the webinar today because I'm excited about the potential for our partner, Second Nature's solution, to help you with the stormwater challenges facing your communities. I've seen a lot of those challenges personally here in St. Louis as we've faced more extreme rain events here in recent years. And Second Nature's solution is a truly modern implementation of Esri's ArcGIS system. And I'm confident you'll leave this webinar with a better understanding of how to turn stormwater runoff into a resource. And with that, I'm going to turn it back over to Chris.
Thanks, Dan. Wilson, how about you?
Hey everyone, I'm our solution engineer, so essentially work hand in hand with a lot of our customers to use my 6 years of experience in stormwater coupled with my ArcGIS knowledge to help deliver solutions for stormwater managers, county managers, etc.
Well, thanks, Wilson. And folks, my name's Chris Capelli, and I'm the president of Second Nature. I've been with Second Nature almost 2 years now. And prior to that, I worked at Esri for 30 years. So it's a real, it's been a real privilege to be able to think about how to leverage GIS to support the important work done in stormwater. And I really think that's the focus that we hope to communicate to you today in this webinar. Wilson, why don't you go ahead and share your screen again? We'll just start with a few slides to offer some context on the challenges. So I think obviously Dan mentioned this, rightfully so. All across the U.S. now we're facing a kind of a new normal, and that's more intense storms that are putting down precipitation that we may have seen in a year, but are now experiencing in hours. And I think that challenges every urban environment because of obvious factors, Wilson. Things like the fact that we do have more intense precipitation. We have asset management challenges and aging infrastructure challenges. Not only that, we have urbanization, which has introduced more concrete into the natural environment, making it easier for that water to hit the ground or hit the pavement and start to form runoff, which moves across the pavement much faster and is harder to control in some cases. So I think those things, coupled with the fact that funding, resources, and competing priorities are constant challenges. And like you, I'm sure you've seen the WEF survey results from 2022, and you notice that that's a challenge that stormwater programs across the U.S. are reporting consistently. Funding, aging infrastructure, challenges keeping up with everything. So I think this is something that we obviously need a change because we can't change the weather, but we can change our environment and how we approach the challenges. Go ahead, Wilson. And I think the purpose, that we see today is in delivering this webinar to you is sharing our ideas on how to elevate your stormwater program using science and, of course, GIS. This notion, again, I'm new to stormwater in many regards, but what I've definitely encountered in meeting with programs across the U.S. and in the Midwest, there's still a high reliance on paper forms and spreadsheets, and in some cases, siloed efforts, where it's challenging to get data to flow across the different parts, because in fact, stormwater is a team sport. It takes resources from across a city and engagement with outside stakeholders to really make it work. So what we hope to do is show you a pathway to elevate your program up to its next logical level in a rational and straightforward way. In many cases, we're seeing programs now wanting to go beyond compliance to really start to influence this notion of urban land planning decisions. And I think that's a really good vision that we're starting to see become reality in many communities. Go ahead, Wilson. So we're going to present 6 aspects or elements of strategic stormwater management. Obviously, leveraging GIS, bringing GIS and stormwater together. And we'll cover each of these 6 as demonstration vignettes to be able to illustrate what each of them really could mean for you and your organization. And very likely you're already doing some or all of these things. So let's go ahead and start. Wilson, I'd like you to focus on doing number 1, assessing the landscape, quantifying the existing impacts, and then also maybe go right into developing plans for drainages and high consequence catchments.
Yeah, sure thing, Chris. I'd be happy to.
Thank you.
Starting with number 1, which is assessing the landscape, we're starting with a map. And this map is really visualizing the power of stormwater modeling mixed with GIS, because what we're looking at is an MS4 boundary or any regulated boundary, but in this case for the city of Clean Water. And inside of that, we have all of those catchments, subwatersheds, essentially those smaller, hydraulic areas that are broken down inside the city. Now, each one of those catchments, subwatersheds, is a different color, which is just indicative of the runoff rate. Darker colors mean more runoff is being generated, so those darker areas are your areas that are contributing more to flooding. And in this particular case, we're looking at baseline runoff. So if we're thinking about showing impact of our program, this is going to be that baseline or that starting line. So if there were no control measures on the landscape, how much runoff would be generated? And if we look in the bottom left table, we can see the total runoff volume generated from the landscape, as well as understanding that about 44% of stormwater is running off. But we do have stormwater programs. We have control measures in the ground to capture some of this runoff. So we want to be able to show that impact. So if we go to current runoff, what we're going to see is these darker areas become a little bit lighter, indicating less runoff. And then we can also see all of those structures where we're getting that runoff reduction from. In the bottom left table, we can see all of the impact of our existing stormwater control measures quantified. Now, this is a stormwater runoff model. We can do the exact same modeling for pollution using particulates as a proxy. So right now we're looking at that baseline value again, if there were no control measures with the total pollution or particulate load down in the bottom left. And then we'll show that reduction thanks to our existing stormwater control measures. And as a program manager, what we want to focus on is this almost sub-catchment level. How do we focus into more digestible bits, those areas that are contributing most to runoff and pollution, to develop a plan for those areas? And what we want to do is just understand the entire landscape and focus in, again, on those darker areas. So in this case, let's say I'm a stormwater manager, probably already have a good idea where a lot of flooding takes place, but this just really helps visualize that and tell that story to upper management or other stakeholders. And as I drill into a particular area, what you're going to see is the values in the bottom left table are going to kind of aggregate just for that particular receiving water. So I'll click on the receiving water and we get those values at the bottom left. And as I zoom in and focus on one catchment in particular, again, we're going to see those values automatically update, giving us an idea of what we're working with as far as runoff in this case. Now, understanding all of those assets across the landscape and the overall condition of the landscape is also important for developing this plan. By leveraging a variety of different base maps, we can get a better idea of where this catchment is located on the landscape. In this case, right in a floodplain. It seems very common, right? Everyone wants to build right up to the water. It doesn't want flooding. And we can get a better understanding of some of the stakeholders in this particular area by looking at things like land use. We now see that we have single family residential, so maybe an HOA, and we also have multifamily residential. So it just gives us a better idea of who we're going to be communicating with for any of the plans we come up with. Now, we want to leverage those existing GIS layers things like what's our storm drain network and where are our outfalls to understand how water is being transmitted through this particular catchment. By looking at flow routing, we can see that water is moving from top to bottom based on the arrow. And then we can also visualize all of those structures that are contributing to reducing runoff. Now, if you remember, we were reducing about 6%, and this kind of tells us why. We have all of those different stormwater control measures, and most of them seem to be performing poorly based on their last inspection. If I want to get additional information about these to figure out which one of these assets I want to prioritize, all you have to do is click on a particular asset, and then you have all of that structural information to help make that decision. Things like treatment capacity and footprint tell us how large the asset is. The facility and street address give us an idea of who this might belong to. And then on the far left, we have some of those core decision-making factors like the consequence of failure. What's the severity if this asset was to fail, as well as the drainage area, just understanding how large of an area this particular structure is going to treat. And so we can say that if we had limited time and a limited budget, this might be a good structural BMP or stormwater control measure to focus on just based on some of these attributes. Now, we're looking at structural controls now, but non-structural controls are also very important. So as we look at things like street sweeping, we can start to quantify the impact of some of these high-value non-structural control measures. By looking at different factors and GIS considerations like curb access, how close are we to actually getting all that sediment on the edge of the street, pavement condition index to understand the overall, is the concrete flat without any cracks, or are there fissures all over it that debris might be hiding in? We can start looking at things like debris accumulation rates. Now, this debris accumulation rate is going to give us an idea of exactly that, how much debris is accumulating, and street sweepers can go in and record their sweeps, cataloging all of that core information for reporting at the end of the year. That's not overburdensome for them, so that way they actually want to use data entry, digital data entry. So things like curb miles swept and amount of debris collected, as well as a spot for photos in case there's cars parked in a no parking area during sweeping days. Now, by taking into account the operation and maintenance of our program, we can start getting things like modeled predicted road conditions. We see that the road went from being in poor quality to good quality, which is really good. And then as we overlay other stormwater infrastructure like catch basins, we get an idea what kind of impact street sweeping might be having on reducing operation and maintenance of our catch basins, as well as improving overall water quality. And then at a full city or county or regional level, we start looking at zones that might have ample sweeping and might be in really good condition, and make strategic decisions to, in our planning, to go forward and maybe utilize some of those resources in areas that have poor street condition to get higher return on investment and see more overall impact from our street sweeping practices. Now, all of that information, we're kind of making a plan for how we're going to approach things moving forward, is being aggregated and modeled right back here where we started. We now have an understanding of why we're not getting a lot of runoff volume, because these assets are not in good condition, and we've identified maybe one or two assets that we can reach out to the landowner or improve if it's a publicly owned asset. And we know we have street sweeping practices. And so we see that reflected here, where we're getting a decent amount of sediment capture. And as we improve some of these structures and maybe enhance street sweeping, we know a representative outfall to make sure that what we're doing on the land is affecting the quality of the water and reducing flows. On a year-over-year basis, we can look at this exact same information to track program impact and efficacy in a long term. So with that, I'll hand it back over to Chris.
Thanks, Wilson. That was fantastic. So I think what was really interesting to me about what Wilson did is he broke the problem down into constituent parts using catchments, a kind of a natural unit for doing just exactly that. looking at what challenges face specific areas of the city, and then being able to address that using data and analytics. Now, one thing I know people often ask us is, well, I don't have all that data. Can I start without all that data? And the answer is yes. Again, I think stormwater done well is done incrementally in most regards, because no one has all of the data possible. But as you started to see, it's pretty straightforward to be able to capture that catchment layer for your GIS. We actually have a video tutorial on how to do that with ArcGIS Pro in the Living Atlas. So you could do that rapidly. I think the second thing we find is a lot of people have assets that are already digital in their GIS, or they have them in different formats. And I think charting a path towards eventually having all of your assets in ArcGIS is a good vision to have and a good goal to set. So I guess I just wanted to answer that common question we get is, can I start without having everything? Yes, that's actually how most of our users actually work. So Wilson, why don't we go on to the next section, because I think as everybody's seeing, we're kind of moving along a progression here.
Absolutely. So this next section is about adjusting those day-to-day tasks or the tactics you use in your stormwater program. And whenever I think of, day-to-day tactics, the first thing that my mind goes to, just working with folks across the country, is going to be catch basins. There's a lot of them, and you have to inspect them pretty frequently. Once, I think 20% a year is pretty much the industry standard. And so what we're looking at is a map of all of the catch basins located across the landscape. And right now they're in 3 different colors. We're looking at catch basins that have a routine inspection that are due, and the ones that have already been inspected are going to be categorized as no issues or having issues. And just like Chris mentioned, if you already have catch basin data, that's great. Bring them right into the system. If you don't, there's a variety of ways to collect new catch basins or even improve the overall data completeness of the data layer you have. And that's leveraging field maps. So what we're looking at right now is field maps on my iPad. And we have 3 different catch basins with one of them selected. Now, if I'm in the field, I have all of this information at my disposal to get a better understanding of what I might be looking at. And if I need to collect any additional information, I have the ability to add that directly in the field, building up that overall data inventory. Now, from here, I can do things like perform site visits. So that information is immediately synced over to GIS, collecting things like photos, whether the asset is accessible, and any structural condition or maintenance tasks that are necessary is right here at my disposal with really simple yes or no questions, just to make training any new staff streamlined. And then as people in the field enter this information, again, that data is synced over into ArcGIS and brought into To Inform, so you can make informed decisions about those tactical approaches. For example, if we wanted to prioritize doing maintenance or inspections on things like assets that have the highest consequence of failure, it's one of those fields that you can collect while you're doing the site inspections. So you're getting that observational data, and you can come in and see how much of your very high and high consequence of failure assets are yet to be inspected or are in poor condition. Additionally, having to-do lists that are just quickly aggregated and compiled, so that way you can make decisions on what assets to inspect next is really helpful just for overall program efficiency. So seeing exactly that information here, as well as all those assets that have routine maintenance. And I typically stick to maps. I'm a map person at heart, but we do have the same information in a list view just to streamline looking at some of that core information, like what corrective actions might be needed. Things like structural damage or debris and clogging. Then as that information is collected, you're performing your inspections in field maps. We also have automatically compiled insight and trend dashboards that help really keep your thumb on the overall program efficiency. And so comparing two different reporting years, we can see how our program might be evolving over time. And we have some of these core metrics that are purpose-built for stormwater management. Things like proportion of visits that require cleaning, so we can get a better idea of how long we're spending inspecting these assets and how dirty they might be, as well as top 5 corrective actions. So if we're getting a lot of structural damage, we can start thinking about our budget for the next 1 to 5 years on replacing some of these assets. And so far we've looked at catch basins, but it's important to have this information for all assets in your storm drain network. Things like outfalls, lift stations, and pipes are going to be some of those critical pieces of information to organize and get a better idea of. And then if you have any data collection initiatives, or you just want to understand the status of each individual asset, you can see that as well. Right now, we're looking at a dashboard of all of the different assets broken down into categories, where the first bar is going to tell us how complete or how fully attributed that particular data field is. Additionally, taking into account things like age, location, and size, we can start predicting probability of failure. So that way, you know exactly what asset types are going to be the largest priority in the short term, while also getting a better idea of your long-term planning. And then additionally, that consequence of failure asset or attribute can be modeled or designated in the field, just giving you an idea of how critical some of your asset types are. Now, this is the what, and of course, we're going to show you the where. And so right now, we're showing you, in this case, all of the pipes across the landscape and the probability of failure. We know that green is good and red and purple are going to be really bad. So if we zoom into a particular area, we start understanding exactly where these assets are that have a high probability of failure. If you have any other departments that are doing capital improvement projects like sewer department, roads, you can come in, see exactly where your stormwater infrastructure is, and get an idea of whether you might be able to work with them on replacing this infrastructure while there's an ongoing project already happening. Just really good to, like Chris mentioned, kind of collaborate with all the different stakeholders involved in managing the system. And then all the data that's being collected in the system is going to be rolled up into an annual reporting section, which is going to break down all of your efforts based on a minimum control measure by minimum control measure basis. Things like program impact are at the top, while things like program compliance are down at the bottom. And our aim here is just to streamline some of the more mundane data collection activities, so that way you can immediately get all of the information you need for reporting in a simple dashboard right here in the bottom left. Each of these assets has a history associated with it, and we can start visualizing where we did our inspections for the year, just to help plan and adjust our tactics moving forward. And then we can see all of the data on a year-over-year basis. Just really understanding the trend of where we're inspecting and the condition of assets in certain areas for as long as we want to go back in time. We are also generating those written summaries that people seem to dread, writing the actual program progress. And so right here, we have something that's completely configurable where it's going to take that information and aggregate it into a nice paragraph that you can copy and paste in any annual reporting, public education and outreach initiatives, or any city board meetings, anything like that. All right. So with that, I'm going to hand it back over to Chris to take us into section 4 here.
Well, thanks, Wilson. So as you see, we're starting to move through 1, 2, and 3. So I think maybe we've mentioned ArcGIS and kind of the integration and why that's so important. Wilson, how about the next slide? Thank you. What's important to understand is that we're talking about creating a system for your stormwater management activities. And that system is tightly integrated with Esri ArcGIS. So that the various people across the city and your external stakeholders are all using kind of that same system of record, so to speak. The idea being that by being able to leverage Esri's tool sets, including, as Wilson showed you, field maps, you're collecting authoritative information while you're in the field and updating and adding to your inventory and making sure that it's as accurate as possible. Now, I mentioned before that a lot of our users start with not all of their assets captured, and that's just the reality. I think by having the ability to take an iPad or an iPhone or an Android out into the field and be able to identify something that's missing and be able to immediately add it into your system and update the information about it, gets you started very fast. And matter of fact, we have many programs that do exactly that. They focus on an area, they go ahead and they do an asset survey and collect the missing information, whether that's the location of an asset or the information about the condition of the asset. So there's two ways: day-to-day work, capturing and updating your information, and then focused efforts, you'll soon collect the data that you need to be able to be kind of fully operational with a stormwater management system. I think the other key aspect is that, we keep mentioning kind of our system, we call it To Inform. To Inform is a modular system, meaning we've created a module to match the various things or requirements of stormwater management for the typical MS4. And as you're kind of seeing the modules there in light blue, you're probably seeing the different components of your MS4 permit, and that's very intentional. There's a series of other capabilities we've added to really focus on the science, to give you the planning and analytics necessary to be able to do that catchment by catchment analysis, or to understand the effective lifespan of your assets in the field so that you can do better, more informed capital planning activities. But again, I think the key is that by tightly integrating with ArcGIS, you're assured that you're practicing that team sport and making that data available not just for stormwater purposes, but informing other departments across the city, including the planning department or the highway department, as Wilson mentioned. And of course, stormwater is not an island. It works with other parts of public works in many cases. Public works generally has asset management systems or work management systems. And of course, using ArcGIS, these systems can be stitched together to work seamlessly. Next slide, Wilson, thanks. So thinking probably now we should go on to number 4, which is really making those investments in projects to alter the landscape strategically. And I think, our sense of using that word strategically is when you have the right data at your fingertips, you can make better, more informed decisions. Pretty logical concept. Data-driven, I guess, is another way of thinking about it. But what we wanted to just show you was some examples of what that really means and what's possible. So Wilson, back to you.
Yeah, thanks, Chris. So alter the landscape is something that is kind of near and dear to my heart, being from the Midwest, because it's just one of those tools to help you actually plan where these capital improvement projects are going and show the impact of your individual city's contributions, to have a more informed kind of understanding of what you are in control of in your permitted boundary. And so an example of this would be looking at a particular receiving water that might have an impairment on it. Now, some of these TMDLs that are on these water bodies don't take into account, one city's contributions. They're taking into account all of the runoff that goes into that, whether it be urbanized runoff or non-urbanized, like agricultural runoff. So it's important to understand your individual city's contributions, so that way you can have a more collaborative communication with any regulatory body. And you could say, with our current practices, we're reducing 25% of all of the pollutants we're responsible for entering this particular receiving water. Now, if you have city goals to maybe reduce more of that pollution or runoff, we have tools that are going to help you manage those projects across the landscape. Now, what we're looking at are a variety of different projects and their associated phases. So the planning phase is really going to be more of that conceptual phase, a what if. Design is going to be kind of once the engineers or whoever's designing these projects get their hands in and start working on the actual sizing and drainage. And then you have your construction projects for construction inspections all the way through to completed or projects that might be shelved or rejected. And each one of these projects, just like any other asset in the system, can be added directly in the program. And by doing so, you get some immediate information about the project. All this information is going to be pulled from existing GIS layers, such as the physical constraints, like what's the slope or hydraulic soil group, as well as those social constraints, like is it in a disadvantaged community, or the aquatic biodiversity score for overall ecology. And each one of those kind of lines of information are going to be some of those critical pieces of information to make you really competitive for grant funding, for installing new infrastructure using that grant funding. And so associated with each of these projects, we also have all of the information added by maybe one party or just various parties inside of the city. Things like the overall assets, what assets are in the project, what's their capacity and their impervious area and drainage, or contacts that might be responsible for this project. Additionally, any files and plans, things like O&M plans, justifications, 30 or 60% designs. All of that information is stored in one centralized place. So if the project was to get shelved or you needed to justify the overall project in the future, all of that good effort and all that time spent is not gone to waste. You have it there for future reference. And then again, each one of these projects contains all of those different assets that are going to deliver water quality benefits. And what we looked at in the current runoff were all of these completed projects. But here's the trick. In the platform here, you can enter projects that are in those conceptual phases to try and understand what their impact will be before you spend substantial amount of money putting them in the ground. So that way you're making sure that these assets are delivering the intended benefits. So instead of current particulates, we want to look at the potential particulates or potential pollution reduction if those projects were to be put in the ground. Each one of these projects has an individual calculation for how much runoff as well as pollutants it's removing, so you can make sure projects are in the right size in the right place. And then you can also visualize how close you are to meeting overall city objectives right here. So you can see your current reductions and your progress toward potential reductions. Really thinking about that watershed planning, making sure that plan is going to be as effective as you need it to be. Just again, making some of those informed decisions. And the nice part about this is you can run the model in the platform as many times as you would like. You can add and remove projects until you get those delivered benefits that you need to see. All right. I'm going to hand it off to you, Chris, to take us into the next section here.
All right. Well, thanks, Wilson. You mentioned that, and I mentioned something about grant funding, and I thought I'd share with everybody. One of our users actually just applied for $38 million worth of federal grant funding. And their proposal was pretty substantial in the sense that it was backed by a lot of information, data. And in their particular situation, there is a community that they're working very hard to protect and balance that against release into an impaired waterway. So the proposal they put together, obviously it's early still, but I would say when you are able to substantiate your proposals with hard facts and data, I think you have a better chance. So Wilson, I think that was an excellent point you made there. as we kind of move around, you're kind of seeing that logical progression. Now, obviously, you don't have to do these in order. I think, some people will start on just focusing on collecting their data and getting their operations a little bit more streamlined, maybe getting rid of paper, and being able to grow over time. And that's really what we wanted to emphasize to you. But we also wanted to show you a bit about what is possible and what are people doing currently. And I think the next logical area too is the things that are just routine, being able to respond to emergencies and curtail any harmful impacts on people and the environment. And I think this is another area where GIS really shines. And by being able to share that data effectively using GIS, you can engage, constituents, the public. You can also engage other stakeholders, emergency responders, and other agencies within your city or county. So Wilson, back to you.
Awesome. So this emergency response, I also think of it as rapid response, is just being able to respond to those illicit discharges in this case that you notice while doing dry weather screening, or a lot of times the public is going to reach out with, if there's any spills, anything like that. And right now we're looking at different representative outfalls that you want to do dry weather screening at. And it's just really important to keep, some kind of standardized form or standardized process in place. And that's what we've worked on developing here. So with our dry weather screening, not only can you collect core information about that asset, going back to just collecting additional attribute information, but if there is a flow present, it gives you a place to record all of those vital field measurements. Things like how much is coming out of the pipe with flow estimation, or those visual observations, kind of your senses, right? What does it look like? What does it smell like? That kind of stuff. We do have some programs that are going as far as actually collecting the in-field measurements, things like pH directly in the field, so you can record those directly in the platform. And then one thing that, as someone who has done illicit discharge sampling, I find very invaluable is being able to collect the sample in the field, record the sample ID in one place, and then whenever you send that to the lab, you can actually record that lab result directly to the individual inspection. And what you're getting with that is the storage of the geospatial information, the exact inspection, which also has date and time. So it's just a repository that has all of that vital information if you need to do any, retrospective investigations. Additionally, if the site does have illicit discharge, you can schedule any of those follow-up inspections. Just like with any other assets, this would populate a to-do list to help you stay on top of any activities you need to do. And then using all of those GIS layers we looked at when we were developing a plan, here's another area that they're extremely useful. Turning on things like imagery, and a little blue dot would appear, as well as all of those core stormwater infrastructures like storm drains, catch basins, manholes, all of that infrastructure that you can use to perform a more logical as well as upstream inspection to supplement your in-field protocols. So by clicking on the catch basin, we can do a dry weather screening and actually trace that illicit flow upstream. And then as you have incidents that occur, so maybe public reported incidents or something along those lines, you have a centralized place to put all of those as well. And there's 3 different kind of performance tiers we want to focus on here. The first is actually cataloging when that new incident was first reported. That's the blue dots here. The next is whenever you went out and started performing an investigation. That's the red stage. And then all of the black dots here are going to be those closed investigations, just letting you know that they've been resolved. Now, at a high level, what we're looking at is the beginning of almost like a hotspot map. You're starting to identify some clusters of illicit discharge activity, and then you can turn on things like land use to understand what kind of land ownership these are happening on. So as we're thinking about where these spills are taking place, we can start having a say in maybe rezoning, saying, hey, well, we're getting a lot of specific type of illicit discharge off of a certain type of property, we might want to think before we convert that multifamily residential to a commercial. Additionally, we do have some clients that are working with their regulator to actually tailor their illicit discharge investigation program based on some of the information gleaned here and tailor their public education and outreach specifically to particular landowner types. And then all this data, just like everything else, is going to be rolled up into the Insights and Trends dashboard, where again, you can understand how your program is evolving and some of the more routine issues that are occurring across the city, county, or just regional boundary. All right, so I'm going to give it back over to Chris, and we'll get into the last step here.
Wilson, you just showed another example of why where matters. Being able to kind of focus in and target areas for public education and outreach. That's my mind was starting to click, which is obviously the next part of the presentation. But I think just the idea of being able to pull this information together in one place, GIS, and then use it in many ways is a very powerful idea, and why we see so much promise in this notion of kind of bringing stormwater and GIS together. So on that role, how about if we go to the next slide and we'll talk a little bit about engaging stakeholders, the public, and policymakers. Because communications and storytelling is essential, and doing that with data and the ability to help people understand where and why, and maybe even how. How can they help? Where can they help? And why? Why is it worth their time? We're seeing our users make tremendous use of being able to address those three aspects. Recent example was, as Wilson had mentioned, by being able to inform people based on certain categorizations of land use in certain areas, so that they could correct some of the behaviors or better informed about those behaviors and the consequences they have on the environment. I think the other we've seen very recently is a street sweeping campaign to help inform citizens of the value of the street sweeper, so that they could get to the curb more effectively and clean up those small particles and debris that otherwise are going to go right into impaired waterways. I think the other thing to mention is that Esri obviously has a tremendous array of tools to help in public education and outreach, from leveraging Esri story maps to creating a hub site. As we all know, MS4 permits require public education and outreach efforts to have a web presence. And, in many regards, ArcGIS Hub and Hub Premium are really great hosts for that, because they add that ability to have data and interactive experiences for people so that they can really understand those three aspects. I think last but not least is being able to engage your policymakers within your city or county by being able to provide them with information relevant to help them understand and inform how they're making decisions and how they're engaging the public. So enough said. Wilson, how about you take us into that last section?
Absolutely. So this last section is going to talk and really illustrate exactly what Chris was talking about. But what we wanted to focus on today was engaging those stakeholders across the city that actually have stormwater assets on their property, right? Those post-construction stormwater control measure as structural B best management practice owners. Obviously, stormwater affects everyone, so everyone's a stakeholder. But these people in particular have some of those assets that can deliver immediate flood reduction benefits and water quality improvement benefits. So making sure we keep them engaged is something that we've heard across the country is going to be really important for a lot of programs. And so right here, we're looking at all the different completed projects across the city. And you can filter all this data in whichever way you want to get more information as you have questions about it. Each one of these projects, just like we looked at earlier, is going to have things like project name, ownership or responsibility, as well as all of the different structures in the individual projects. And since we have all that information for each of the projects, we go back to our to-do list, and this is probably one of the only times I go to a list view first. But we have these lists that tell us who we need to communicate with via formal communications and who has not responded to our communication and needs to do so. So by using that information, we can click on one of these projects, generate a form automatically. There's our O&M contact. We'll set a response due date, and we'll go ahead and sign this. And as we preview this form, this is what's going to be automatically created with fully customizable headers and language with information about the assets on the property, whether it be 1 or 10, as well as a URL or a QR code to scan that the private landowner can enter on their side. And what that does is it takes them to their own collaboration portal. This is a form that the private landowner can fill out and include information like their response date, whether they maintain the asset, as well as additional comments, photos of the asset, and any of those files, such as a asset-specific operation and maintenance plan that was delivered to them during the construction and permitting phase. As they fill out this information, it's recorded into Inform, so you can come down, see their response, and approve or deny the request, and actually collaborate with the landowner back and forth. This information is then, again, in a nice dashboard, so that way we can take our limited time and focus it on those people that are unresponsive, all while having all of that data captured, so we can just look into trends once we do have time. Again, understanding the where, now we are seeing where these projects are and who is unresponsive to see if there are particular neighborhoods or trends in the data that we can get ahead of with any of our hub pages or public education and outreach initiatives. And as we perform those, we can keep all those initiatives in one centralized place where we can add new activities and keep all of the core information like target audiences, number of impressions and attendees, all centralized and pulled into the annual report at the end of the year. With that, I'm going to close out the 6 steps here and hand it back over to Chris.
All right. Well, thanks, Wilson. Not going to let you off the hook quite that fast, but go ahead to the next slide. I think what we wanted to get across today was obviously that there is a way to bring together stormwater and GIS to leverage a system as strong as ArcGIS as the foundation to build kind of a next generation of stormwater management capabilities. In terms of Second Nature ourselves, we are proud, obviously, to be an Esri partner, and we're largely a team of stormwater scientists and GIS experts and software engineers. And it's our mission to deliver the tools that help you and your organizations become more resilient and address the challenges of stormwater management. Next slide, Wilson. I think our sense is it is feasible and practical, especially in 2023 and 2024, to leverage modern technologies like ArcGIS and to Inform to move any program all the way through to being an effective digital program with integrated workflows, making data-driven decisions. And of course, we stand ready to offer our assistance if you'd like to engage us to even just talk and understand your program and your vision for where you want to take your program. Not just with our tools, but also just with respect to leveraging ArcGIS. So with that, I think we can turn off the slides. If Dan's there, we'll let him come back in and just wrap this up. Dan, any closing comments?
Hey, Chris, thank you. Thanks, Wilson. Thanks, everybody, for attending. I mean, I hope all of you got an understanding of just how comprehensive of a solution Second Nature has to help you with your stormwater management programs. Look, I mean, Chris mentioned he's been with Second Nature now for 2 years. He's still becoming an expert in stormwater. I by no means am an expert in stormwater, but I've certainly seen the implications and the challenges it has for many of you. And what I really like about this kind of goes back to something that Chris mentioned, is that you don't, no matter kind of where you are on that spectrum of the maturity of your program, you can jump in and you can start getting value from the solution that they've built. And again, like, I can't emphasize enough that this solution really does represent a truly modern implementation of the GIS technology that many of your communities have already invested in. So that ability to communicate with others in your organization, stakeholders, share to the public, those are all very important aspects of the solution. And I'm just excited that you had the ability to sit in, and hope you'll reach out to Second Nature or your Esri account team if you have any questions. Thanks, Chris.